Hello students, welcome back. Let's resume section 3. Previously, we studied the relative rate of change, y prime over y. And then we went through an example problem that came from biology. That much is required to everybody, the first 1/3 of this section. Now, how about the latter 2/3? Well, that part is not for everybody. The latter 2/3 of this section is rather intrinsic to business calculus and financial calculus, and also calculus-based economics or econometrics. If you're interested in any of those, please stay here and pay attention. This is going to be important for you. If you're not majoring in any of those, but if you still take interest in application of calculus in models that are represented and measured and calculated in monetary units, such as dollars or any other currency, in that case, you're welcome to stay and pay attention. You may find this topic interesting. But if you're not into any of those, no business, no finance, certainly not economics, you just want to study something on, say, life science or health science, that's it. In that case, you can skip. If you're going to skip, skip now. If you're going to stay, okay, here we go. And I'll assume that you're taking at least some interest on these kind of topics. So I'll explain this with a lot of digression. Most of those digressions will be coming from economics, but some of them may be from business or finance. Okay, here we go. Suppose that the price P and the quantity Q of the demand of a certain product or commodity are related implicitly. The elasticity of demand is defined as this ratio here. Let me expand the font so that you can read better. The elasticity is defined as the negative of Q prime over Q over P prime over P. That is, the negative of the relative rate of change for quantity over the relative rate of the change for price. Here, the quantity is the quantity for the demand. You can establish something similar for the elasticity of supply if you change the numerator as the relative rate of change for quantity associated to supply. In terms of mathematics, there's not much difference, but in terms of economics or business, they may be quite a bit different. But for us, it's not that important because we are going to focus upon mathematical aspect. So let's focus upon the elasticity of demand in this case. So here, the quantity is always on demand side as far as this notebook is concerned. Now, what about this negative sign here? I'm going to explain it a little bit later, but typically this quantity is already negative. So we put extra negative to make this entire quantity, elasticity, as a positive number, but it doesn't always work. I'll talk about it a little bit later. First, the mathematical aspect of it. So the elasticity is defined as this expression here, but then again, that's too complicated. We have fraction of fractions, too many denominators, too complicated. Is there any way to simplify? Yes, there is. And here are a couple of simplified versions. This one and also that one. Well, how do they work? Well, let's see. Let me copy and paste. That's the definition, so let's start from here. Copy and paste. And then let's do this simplification. We have too many denominators, so multiply all those denominators to both the numerator and denominator. That is, multiply P times Q to both numerator and denominator. And do you see a cancellation? This Q and that Q will cross each other out, and this P and that P will kill each other off. Do you see that? So this goes out. And then this goes out. And of course, we get this quantity as a result. Let's rewrite as this quantity. Okay, we're up to this. What do you do next? Let's rewrite this thing in German notation. So instead of q prime, let's rewrite as dq dt, and this one becomes dp dt. Now, do you see a simplification here? This dt and this dt down here, they cross each other out, and what's left is, of course, a desired quantity here, the first expression. Do you see that? As a matter of fact, this crossing, this simplification may look algebraic, but as a matter of fact, deep down, it's a chain rule. It's due to the chain rule I can cross these out and get this cancellation. In any case, we completed the proof. But if you're not too much into the proof, it's okay. At least remember this. This is the definition, but here is a simplified version, and here is another manipulation. Now, when do we use any of these? If P and Q are related implicitly, but the relation is rather complicated and cannot be simplified, then this is going to be more useful. You can take the derivatives implicitly, and then you get P prime and Q prime, and try to get the ratio somehow. Now, if your relation is very, very simple, so that you can solve for P or solve for Q, so that you can calculate the explicit derivative, then this may be a bit more useful. We're going to talk about those computational aspects in the next example, but for now, let's have a little bit of digression, because what do they actually mean? That question has to be answered first. Okay, so let's postpone the algebraic or analytical aspect of these. Instead, some more lingos. Economists and marketing analysts use these kind of terms. When the elasticity is greater than 1, we say the commodity is elastic. When it is less than 1, then we say it is inelastic. To be elastic, this whole quantity has to be greater than 1, which means the numerator has to be bigger. So the relative rate of change for the quantity of demand should be greater than the relative rate of change for price. When do you have these kind of situation? That is, price change a little bit, but the quantity of demand changes a lot more, or just a little bit more, so that this quantity is greater than 1. A lot greater than 1, then even more elastic. Can you think of that kind of example? And vice versa, when does this thing less than 0? That is, the denominator has to be bigger. So the relative rate of change for price is bigger than the relative rate of change for quantity of demand. So the price may change a lot, but demand may not change very much. Can you think of that kind of example? Well, let's consider this elastic case. Gas price is going up. So airplane tickets go up. So people cut down on traveling. And consequently, travel industry take it. Yeah, you can think of those kind of situation. So the price may changing a little bit, but a lot of demand go out. That kind of things can happen. Yeah, these kind of things can be elastic. How about the other way around? Well, gas price is going up, but You may be able to cut down traveling, but you cannot cut down on commuting, see? And you still have to work. You still have to pay for bills, and even more so because things are becoming more expensive. So the change of price may be big, but the change of demand, not very much. Those kind of things are inelastic. Usually, the consumer staples are inelastic. Gas price, I said before, and food, the egg price is going up, milk price is going up. So you may have to cut down your consumption a little bit, but only to a certain amount. You still have to eat, and you still have to feed nutritious meal to your children. So those are inelastic. Elastic cases, those tend to be some luxury items, such as, travel cost and those kind of things, jewelry or whatever. One more additional comment. I told you about this negative sign before because we need the extra negative because this quantity, highlighted quantity, tends to be negative usually. Why is that? Well, the change of demand and the change of price are usually negatively correlated. If, say for example, copper price goes up, then a lot of industries that use copper will try to cut down their spending and try to reduce the inventory and things like those. So in a good environment, the demand goes down, and that gives you the pressure on price. So price goes down again, so they stabilize roughly. So this quantity here, the relative rate of change for quantity and the relative rate of change for price typically have opposite signs. So this quantity is already negative. So by putting extra negative, you can make the entire fraction here, the elasticity, as positive quantity. And that's why you're using this negative sign here, extra. That's why we are using this extra negative sign there. But that doesn't always work. In some case, in bubble economy or something like that, even the price goes up, demand may go up even further. And then there are some commodities, or there are some items, some products work typically that way. For example, gold price is going up. And will the people try to cut down the gold consumption? Wait a minute, people do not consume gold. No industry actually consumes gold, or very few. They hoard up gold for investment purpose, or short-term investment or trade. So what typically happens is when gold price goes up, then people or traders demand even more in a hope that the price will appreciate even further. But of course, nothing will go up forever. So at some point, it'll stop and bubble pops and then everything just come crashing down. Those kind of things happen. Yeah, they do happen. Now, if you're running a government, if you're running a country, then you have to slow down those kind of things. Always there are ups and downs, but not crashing down or bubbling up. Move slowly. That's what you want. And that aspect is economics. Now, if you're running a business, that you may want to ride those kind of bubble for a short term, or maybe you'll have to protect your business from that kind of thing. Well, that's the rule of that's the aspect for business or finance. So all those are coming together here. And the mathematical aspect of it is basically this, the ratio of relative rate of change. And then it can be simplified in this form or that form. We're going to talk about how to utilize these computational formulae in the next example, but we are out of time, so let's stop here and let's discuss an application problem in a separate video. See you soon.